Hello and welcome to the Rubber Duck Dev Show. I'm Chris.
I'm Greston.
And tonight we are going to talk about the sweet hell that is date time. Oh God, somebody shoot me now. So,
It's not bad to talk and complain about it, but it's bad to code it.
Oh God, yeah. Well, I don't know. I'm going to start talking about some things that may just make you change that sentence. So, anyway, here we go. So before we start talking about how to code this stuff, let's talk about how to understand it, because it's kind of weird. Now, time zones. Time zones are a bit crazy. They are basically how we shift time around the world so that people, so that it's not 11 a.m. somewhere where it's pitch black in the middle of the night. That would be goofy. So they're based off of UTC, which is Coordinated Universal Time. So already they've screwed things up because the acronym doesn't match the words. So that's just dumb. So
and forever I was always thought it was Universal Time Convention.
Yeah, no, it's Coordinated Universal Time. So it should be CUT, but it's not. It's UTC, so they can't even get that right. So how are they going to get the rest of this right? Well, the answer is they don't. That's also called Greenwich Mean Time. So that's your 0 hour. In the military, that's called Zulu time. So Z hour. We'll see that in a little bit. So any rational person would think that there should be 24 time zones, because there are 24 hours in a day and each time zone just shifts 1 hour. So every 15 degrees across the world, around the world, you should shift an hour. No. There are over 500. Why is that? Governments are awesome.
Politicians.
Yep. So, okay, so there's 500 time zones, which means there are more time zones than there are countries. Okay, I'm okay.
That makes sense. Large countries have more than one, like the US.
I mean, yeah, there's several in the US. There's a lot in Russia. I can deal with that. 500 is a little excessive, but okay, sure. So you would think that a time zone would just be UCT plus or minus some number of hours. And that's mostly true. Except Australia has a 30-minute offset. I love my Aussie friends, but screw their time zone, because that's just crazy. But even better, India's standard time is also a 30-minute offset. Okay. And that's all the way across India, which technically spans 3 or 4 different longitudinal time zones, or should, but it doesn't. But it gets better. Wait, so Chatham Island in New Zealand and Nepal have 45-minute offsets. How that's a thing, I don't understand. How does that help?
Clearly no engineers have established these zones.
Right. So, yeah, and we'll look at a couple of them in a minute. It's like some drunk monkey was painting lines on the earth, and I don't know. All right, so then, if that wasn't bad enough, we have this whole concept of daylight savings time. In some places. If you're in a place that doesn't have daylight savings time, what that means is, in the spring and the fall, your time zone changes an hour, either forward or backward. It happens in most of the US, and it happens in most of the European Union. That's nice. So now we have to deal with the hours at a certain day in the fall and in the spring moving. Except the US does it 1 week and the European Union does it about 2 weeks later. So while Orlando is on daylight savings time, London is not for a couple weeks. So there's that. That's all nice. Now, you would also think that since the Earth rotates and the sun moves across the sky, and it should be just shifting the time, that they would be along longitudinal lines. But they're not. Like I said before, it looks like a drunk monkey was painting the Earth when you look at these maps. They're all over the place, and they follow more geopolitical lines than they do longitudinal lines. Okay, I mean, I get that. It makes sense. You don't want to have a country that just because 1 mile of their 500-mile wide country crosses some longitudinal line, those people are an hour off everybody else. That would be dumb. Okay, I get it. But it's not even close to solving that problem. It's just seems like random stuff. So, I want to take a look at a couple of these things and just show you some weird crap that happens because politicians are ding-dongs. So, one thing is, see, here's the drunk monkey painting lines. You would think, and this is generally true, you know, like London over here. So you've got the Greenwich Mean Time, and which is not called Greenwich Mean Time over here. But anyway, you would think that we would just be an hour, an hour, an hour, an hour, and on and on and on. And that kind of works that way for most things. But here we've got Inuvik, Canada, which is very west of Seattle, Washington. But it's an hour behind Seattle. So, I mean, an hour ahead, but it's further west. So that's a little goofy. But wait, it gets better. Over here is Baker Island. It's in a time zone called Anywhere on Earth. Okie doke. But it is pretty much due south. Now, this is a Mercator projection of the globe, so yeah, I get it's a little bit skewed, but not that skewed. It is directly south of Midway Island. But they're an hour off of each other. They're not in the same time zone. But hey, it gets better. Because directly north of Midway Island is Adak, Alaska, and it's 2 hours off. So these three things that are in a line are in 3 different time zones. Not only that, but this heavy line is the international date line, which means on one side it's one day and on the other side it's the next day. So that doesn't follow any kind of
That definitely
sense.
looks like you're saying a drunk monkey drew that on the planet.
Right. So, you know, this is the stuff that all I can say is thank God they've got time zone libraries. Because if you actually had to think about this stuff while you were programming, just no, I'd quit programming.
Yeah, but you say that about a lot of stuff.
Yeah, I know. I'm a whiner. So, anywho, we'll move on to some things you have to think about if you're going to use times and time zones in your app, your web app. So, the first question you got to ask is, should I include dates and times in my app? And the answer is, God, no. Are you insane? Thanks for watching. We'll see you next week. Problem solved. No, but you usually, I mean, a lot of apps have to use dates and times. Unfortunately.
All of them do.
Yeah, I know. And that sucks. Thank you, politicians, for ruining programmers' lives. So, another question is, do you use a date object, a time object, or a date time object. So what are your thoughts on that? Kind of depends on the language to a point, but
Yeah, it depends on the language. It depends on the database because different databases support different types of data types. Like, for example, something that's a date time, they typically call it a timestamp. Basically a date and a time. Like talking about Ruby for a minute, is that Ruby 3.0 has deprecated the date time class. So that's no longer in existence.
Yeah.
Or not, it's deprecated. It will go away at some point.
Right.
So basically, if you want times, even with associated dates, you would use the time class. If the only thing you want is dates, you would use the date class. Now, what I tend to use pretty much are timestamps for everything. It's very rarely that I use a date in my app. Even if I want dates, I want to reserve the fact that there's a time associated with it. And we'll get to this at some point, but usually I'm only storing UTC versions of that if I'm mostly concerned about the date. I just store, essentially the 0 hour Zulu hour for that particular date. But I did find out that, well, doing some research that, but the advantage, at least in Ruby, of the date class is that it actually does some calendar conversion. So if your app has to do like a lot of historical backdating where different calendars were used at different times, it can actually do some of that conversion for you. Whereas the time class all it is basically number of seconds since the Unix epoch, which is basically January 1st, 1970. So time is basically just a count of seconds or partial seconds from that time point, whereas dates really take into consideration calendars and whatnot.
And if you're trying to do anything with dates before 1970, just God, because Julian calendar was switched in some places, but in Russia it wasn't switched till a lot later. And then there's these times where there was days that just disappeared, and history sucked with time. So be careful of that too.
Ironically.
Yeah. But yeah, I think my rule of thumb has been use a timestamp or a date time, whatever your language calls it, the full one, unless you have a very specific reason to use the others. Because there's no reason to box yourself in to less information if you don't need to.
Yeah.
In the days of COBOL, when storage was at a premium, there was a reason. Today, not so much.
Yeah, because you're going to easily convert a date time into, or timestamp into a date if you need it.
Right. So another thing you have to deal with is your time going to be displayed as UTC or as each user's local time? So like I'm in Florida, so I would look at Eastern time things. I don't care what time it is in England right now. So I'm sorry, but I don't. I want to know what time it is for me. So your dates and times, are you going to have to deal with time zones and displaying things differently to different people? That's a big question, because that's a whole lot of work that you don't want to do if you don't have to do it.
Yeah, but the libraries do make it easier to do that now, but you do have to learn how to convert it.
Right.
For each person. And
there are gotcha, all kinds of gotchas with displaying in different time zones and stuff, and how do you let the user set that, and all kinds of stuff. So will you store the time as UTC or as the user's local time or as the server local time or as blah, 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 blah? That's a trick question. Store it as UTC. End of story. Don't ever store anything else. The
Not
other
necessarily.
Stuff, well, as a string, yes, but if you're doing in a date time field, I would never, ever store anything other than UTC. Why would you do that?
Because, for example, the Postgres database supports storing a timestamp with a time zone attached to it. So there are some people so Rails, by default, every single timestamp it creates is a timestamp without a time zone. So basically the easy path for Rails is to store UTC times everywhere in the database. And that's what I do. And I set the database system to use UTC time. Whereas I have other clients that are using different frameworks and whatnot. They've set their database to a local time, which confuses me to no end at sometimes, but presumably their app is handling it.
Yeah, but why would you set your database to local time? Why would you ever want to do that? I know you can do that, but you shouldn't do that.
Yeah, I mean, that's separate. So the way they're storing the dates are separate consideration of what they've set the time zone of the database server to run at. So, so that's something. But in terms of storing, I would say there are two acceptable routes. So I'm going to be a little bit different from what you're saying. So,
well, that's it. I quit.
In Rails, like I said, the easy path is by default, when you create a timestamp, it does a timestamp without a time zone. So store UTC there. They do have good libraries for date time support. So you can use those to convert any date time you put in, as long as you have the time zone associated with the user, or you could even make it. I've even considered in some cases for apps, maybe it would be more appropriate to set a time zone at the client account level. So for example, maybe this institution in the Midwest, they want all their users to see the information or the time zone for the account versus each user setting their own. So that's possible to do too. The other way so you do have some more flexibility doing it that way. The other way to do it, and maybe this is more acceptable use case when you're using programming languages that don't have as robust date time support or time zone support, where you store the timestamp and then the time zone it occurred at in the database. Because Postgres does have the facility to convert to different time zones, much like you can in Rails.
Yeah, but okay. So first of all, let me just pick apart your arguments here, because this will be fun. All right. So, what were your arguments? No. Okay. So if you want to display stuff just to a local segment or something, and you're never going to change time zones. Like, let's say I'm in Central Time in the US, and I'm just doing something for a local intranet. Everybody that's ever going to look at it is Central Time, although that's getting to be a rare thing anymore. But I have no reason ever to change the time zone in my displays. I would still store that as UTC, because anytime you say never in a programming scenario, it bites you in the butt. And it's much easier to convert stuff from UTC to whichever other time zone for display. Let's say that I had an office in Orlando, right? Now I've got an Eastern time zone office, and now I've got to convert. Well, instead of converting from Central Time that's stored to Eastern Time, and then on and on and on, everything's based off of UTC. So if I'm always storing in UTC, I know I'm always safe from a bunch of weird stuff that can go on. Even though I could store the time zone information with the timestamp in most databases, though there are some that can't, but stop using those. Anyway, I see absolutely zero benefit to storing it in the database as a non-UTC time.
Well, you can convert it to whatever time zone the user's in. So if it was stored in there and it came in for the Midwest time and someone from the Eastern time zone was looking at it, you just use a Postgres function to pull it out in the correct user's time zone.
Well, right. I know you can. I mean, I get that. I get that you can. But the problem is, especially if you end up having some API or something, then you're going to be passing times, which we'll talk about APIs in a second and what you should be doing with those. But, you know, when you go and do troubleshooting, when you're going and doing all this other stuff, if you're looking at logs, you're doing all this stuff, it's much easier to have all your times consistent across everything and UTC. If I have to look at a time with a time zone in it and then in my head start translating, well, what's the offset for this? That's just I don't see any benefit to storing anything as a non-UTC time, unless I'm doing it in a string that's for something besides just time.
Well, I mean, put it this way. I always store UTC times in my database. I don't store a timestamp with a time zone. So, but of course, in my Postgres research and that I do, or for my Scaling Postgres show, they take a lot of, I've seen a lot of posts that take the other side of the argument that you should always store timestamps with time zones. So really, I'm trying to argue their point, even that's something that I don't do.
Right.
But there is the capability to do it.
Sure.
So I'm not saying I would necessarily do it, but I'm just saying that seems to be a viable path.
So what I'd like to see,
but whatever you do, be consistent.
Oh God, yes.
Don't be inconsistent, or I mean, then you're in for a world of hurt. I mean, I've seen some people talk about how, hey, did my time zone stuff this way? No.
I won't work on your code base if you do that.
There's only two ways: all UTC, or you store the timestamps with the time. Store the time zones with the timestamps.
Yeah.
Even though that's something I haven't used, it should be another viable path.
And honestly, okay, so my argument is you should never use that. You should just store UTC. But here's what I want to do. Viewers, if you have a use case where I'm full of crap and I'm wrong, put it in the comments, because I want to know when I should not be storing something as a UTC time in my database. Not displaying it, storing it. All right, so moving on. We were talking about APIs. Nope, wait, one more thing before we get to there. Should your app, and this is a little weird, but if your app can travel, so for instance, it's something that, like a meeting app or something, and I'm, I fly all over the world, and so I'm in different time zones every other day. Should my app automatically adjust that time zone for my displays or not? Now, that's a little tricky because you can do that on phones, but you can't really do that on laptop sometimes. But is that a thing that you need to worry about? Because that'll make a difference to how you store your information, because you got to be able to pull it back out and display it in different ways for the same person. So, so then you get into, well, is the person going to set a time zone on their account and I always display in that time zone? Or am I going to be looking at the local time zone of the machine? Or, how am I going to display this? How am I going to allow the users to tell me what time zone they want to see? And most of the time...
I would think if you're giving them the option, you choose what they choose. Otherwise, you're going to be using, what the local time is on the system.
Right. but that's, you know, that's a consideration to how you're going to
think
do
about
this.
how you want to do it.
Right. So APIs, we touched on that, and one of the things that this is, I don't think I've ever seen anybody argue anything other than this, but that is APIs should always use ISO 8601 formats for date times when they're passing them through. And that looks like this. So you get a year, month, day, and then your time delimiter, the time in 24-hour time, and then your time zone. In this case, Z is Zulu time, so this is a UTC. But you should always pass ISO 8601 in an API, because if that's not standardized and I'm on the receiving end of your API, I'm going to have a heck of a time trying to parse this apart and do anything with it.
Have you ever seen any APIs where they give a time zone different than UTC?
I have not. And that's, and I never write them that way, because even if I had everything displaying in one time zone, I don't know what you're going to do with that. So I'm always going to want to pass you UTC time and let you make your decisions about how you're going to deal with it. I don't want to make that decision.
Yeah, I haven't seen any, but I was just curious.
Yeah. So, you know, in my opinion, APIs should always be ISO 8601 UTC times. And that's what I expect if I'm consuming them, and that's the way I always write them if I'm creating them. So what else? Oh, we went over that stuff.
Those other 3 points. Yeah, we covered those.
We covered those. All right. So date time parsing. Bleh, you talk about that. I don't want to.
So I actually haven't done a lot of date time parsing, because in a web app, I mean, I've done it, of course, but not a lot. And because Rails, essentially, if you give it a date time, it usually stores it pretty well in Postgres. It has a lot of logic that if you receive anything that resembles the date, it is able to insert it pretty well. But there are cases where I've actually had to parse some dates for some data that I was receiving. And what was interesting is that there's no way to parse dates without using some sort of exception handling, because at least with Ruby, the date time parse tools, either it parses it, and I'll say quote double quotes, correctly, or it throws an exception, throws an error. So either it works or it doesn't work. There's no way to do a conditional statement or there are no functions of convenient functions available to say, hey, is this a valid, try to see if this is a valid date. I wasn't able to find one in the library. There may exist something. So basically you have to use exception handling with it. So it's already kind of makes it a bit different to work with compared to a lot of other things, you work with. Now, one thing that I did discover in terms of this parsing example I had is that it is so easy to get to parse the wrong thing. Like if you just put in a date using like the dot parse function, where you're not delineating this part's going to be the year, this part's going to be, just say throw with something in, you're going to get results all over the map, depending on the date you put in. If you're trying to parse a date time, but you're just giving it a date. So what you would want to do is use I'll call it specific parsing for lack of a better term. You may have a better one, but basically like Rails or Ruby has the strp time, which stands for string parse time. that function, you give it the, say, your string that you want to parse, but then you actually define the format of that string precisely, where's the year, where's the month, where's the day, where's the hour, minute, second, et cetera. What's the time zone? So you literally specify exactly what the format is. I would always go with that to parse a date time as opposed to just using parse, because otherwise you're going to get really unexpected results for some inputs.
And that's precisely the reason why, if I'm consuming APIs, I want them all to be ISO 8601.
Now that's right. So that's an exception to that. If you're consuming a very fixed format, like that ISO, version, then you could use parse, because it's always going to do it correctly. It's not going to be out of bounds in any kind of way.
Right.
But any other kind of date times you're consuming, you're going to need to be cautious.
Yeah. Well, especially user input things.
Yeah.
That's because
who knows what they're going to type.
Exactly.
Because this date time parsing I had to get into was because I was asking for a date with a little calendar click interface, but of course they could type in what they want. And the variety of things that I was getting, had to make sure everything was good.
32nd of March, April. Yeah, thanks. So yeah, and kind of the converse of that is the whole parsing thing is formatting for display, because if I'm a user of your program, I don't want to read ISO 8601. That'd break my brain. So, taking those and formatting them out. So, like you were talking about the string P time, there's a string F time to format the thing. So you give it a time object and then say, I want it to look like this with some parsing string and to display to users. So, you're very rarely going to store these things in human readable form in your database, but you don't want to show them to your users in database form because they can't read them, because ISO 8601. I mean, if I'm a programmer, I can read that. If I'm not a programmer, I stop using your app. Show me what I know. Right? So I want to see Sunday, July 4th.
Now I've got a question. Like, there are some outputs that I give something similar to this on some reports. Why? Because the sorting works
right
super conveniently.
Mm-hmm.
I haven't, I know you can do some extra work for some libraries that do sorting so that you sort on a hidden value. So basically you could make this hidden and you could display the friendly version and it sorts appropriately. But I haven't done that. Have you ever run into having to do that?
Yeah, I have. We did, at one of my jobs, we did a lot of reporting on data, and a lot of it dealt with dates and times. Because it was reporting user input out to back-end consumers. So, and they would want to sort by dates and times and stuff. So what we ended up doing in most of those cases was putting the ISO, if we were doing like a data dump report for them, we'd put the ISO date out, and then we put a readable date format out.
So
columns. So you could sort the ISO date if you wanted to sort by dates, because we were putting out to like Excel spreadsheets and stuff like that. So now Excel can do some date sorting, but not if it's just a string. I mean, it'll do displays of dates. So depending on how the report was formatted, you can actually put it out as an ISO 8601 and it'll just display it as human readable. But yeah, for reporting and online display are a little bit different too, because online display, you're almost never going to want to show an ISO format.
Well, in terms of the online display, it's kind of like in a grid table where you've run a report on the screen and you're literally seeing the data on the screen. There are cases where in that column that it's being sorted by when that date time came in, I use a format that is not dissimilar to what you have on the screen.
Yeah,
because it sorts quite easily.
Well, yeah, and I would have put
But
that
if-
in the reporting category.
Yeah, but when you drill into it, it shows all the nice friendly dates on the
Sure.
Yeah.
So, keep in mind that you gotta work these things both ways. You gotta parse them apart to store them and do things with them, but you also have to format them so that people can read them. So, get used to both sides of that if you're ever going to work with dates and times in your programming, and you will. So, fun. Comparisons. I got to compare dates. I'm actually working on an issue at work with this right now, doing some design work on this. And one of the things that we're talking about is, should we treat these as date times, or should we just treat them as integers? Because fundamentally, the date time or timestamp things in databases are primarily just integers. They're just numbers. So sometimes they're floating point depending on the database, but they're just numbers. So if I just have to do comparisons, should I compare them as numbers, or should I compare them as date times?
Right. And then, so the thing I was mentioning here in terms of comparisons is like when you're pulling ranges of things is kind of what I was thinking about. I generally don't convert to integers or use the integers, but what I generally do is just use the raw date times. And I always use, even though they do have the between functionality, I never use that because it may depend on the implementation, whether that's inclusive or not. I know
Right.
SQL has a standard, but for my peace of mind, I always write stuff greater than or equal to and
Right.
less than another date.
Right. And even though SQL has a standard, that doesn't mean that every database follows that.
True.
Because, so yeah, like you, I always do the comparisons with, I try to be explicit with them, because I can't remember whether this particular language is inclusive or exclusive with its between. I certainly can't expect some other programmer who comes after me to know that. So yeah, those helper functions have become just confusing, and so I stay away from them. They're pretty to read, but when you start thinking about, well, what does this actually mean? You don't know.
Yeah, and working with the timestamp, doing greater than or equal to something, so it's inclusive on the bottom and it's exclusive on the top, and it's less than. That's generally how I do everything. And even if I have like a report that says, hey, you want a set of data from the start date and the stop date. I'm sorry. What I generally do is, of course, the bottom date's inclusive, but I actually make the end date inclusive as well. So basically, I just add a day to whatever they put in.
Mm-hmm.
So it does less than, so it captures everything. So basically, I still always use that throughout my code bases, that convention. But sometimes based upon users using it, that would expect, hey, I'm running a date range for a report. They would expect that to be inclusive at the end generally.
Right. And most databases too, if you're running very large reports with dates and you're trying to do comparisons, you have to think about the fact that for most databases, less than is faster than less than or equal to. So if you're running a report that's going to pull 50 records, that's not a big deal. If you're pulling millions, that's something you want to think about. So do I add a day to the end of this and just do a less than, or can I get away with less than or equal to?
Yeah. And in terms of comparisons, so like I've always just used the dates and the functions and everything that's in the database. I've never done a lot of conversion. The only time I've done conversions to numbers is it seems to be done more in JavaScript. So sometimes if I'm working with JavaScript and Ruby, or I may convert something to a Unix epoch or number of seconds since the Unix epoch. But generally, I always just use the dates.
Right. And one of the reasons that we're even talking about that at work, discussing that thing, is because we're dealing with millions of records, and these microsecond differences in speed are important at those scales. So what we're trying to determine is dealing with this as a number faster than dealing with it as a date especially when we're doing querying and things like that, data manipulation. And I just don't know. If you know, put it in the comments. I'd love to find out. It's something I'm kind of researching right now. But it certainly works better with my brain doing integers than trying to do date comparisons. My brain has a much easier time doing that faster. And I suspect that most databases do as well. Although I think most databases actually just do that under the sheets anyway.
Yeah, it may be doing all of that for you anyway.
Right.
I mean, I'm a huge empirical tester. So if there's a way I could get sample data, large scale sample data that replicates essentially what's in production, just test it. That's
right.
what I would do.
And that's what we're doing. But we're also talking about the architecture and design of the area of the code that we're dealing with too. But it's just kind of an interesting thought experiment that, does it make a difference? Is it better? Because, I didn't used to think that less than or equal to made a difference, but it's actually a significant difference. Okay, so tell me a little bit about this next thing. I'm not sure what your thought process was there.
So talking about Booleans versus timestamps. So I have Boolean data types in my application, and I see them in numerous other applications as well. But what I've started finding is that quite often they get converted to the desire to know when this Boolean came into effect. Like, for example, if something was complete, well, initially, maybe I'm storing some sort of transaction date and I want to flag, hey, it's complete. So I've flagged it complete. Or, hey, it got canceled. Okay, well, I flag it's been canceled. Well, inevitably what comes up is, well, when was it complete? Or, well, when was it canceled? So generally what I've started, if I think, hey, I need a Boolean field here, because, and historically I'm used to dealing with, hey, Booleans are small, cheap data types. They're not big.
Mm-hmm.
But again, the size difference is not mattering anymore, given how large, the capacities of systems nowadays. So, but to fight off that need to actually change the data type in your tables, I would ask the question, if you think you need a Boolean field, do you really just want to go ahead and make it a timestamp? So false would be null for that timestamp, or it will be true if it has a not null in there.
Right, which again, I just did this like the end of last week. I added a deleted at field to a table because we needed to know that something was deleted or not. And we said, well, why wouldn't we just make it a timestamp? There's created at, there's updated at, why don't we have a deleted at? Either we delete it, but if we're going to soft delete it, I want to know when that happened. And that's important because in the deleted case, because when we're purging data, we want to know how old that data is. When did it get deleted? And either this is a really timely discussion, or you end up working with date time stuff way more often than you think you do. I suspect it's that.
Yeah.
Because everything we're talking about, it's like, oh, I just did that last week.
Yeah. Well, but, like I said, it's date times are pervasive everywhere,
Yeah.
Now, and it's not all Booleans, but I would just do a test. Is there any chance that you will need a date time for it? Or is there, or look at it from the other side, it becomes a Boolean if it makes zero sense at any point to be a date time. Like,
Right.
for example, the example I had was something gets placed into a sandbox. Well, but the concept I'm thinking about, it's a binary decision. Either it's a live transaction or it's a sandbox transaction. And there's no migration between the two. So you're not going to say, hey, it was sandboxed at this time. Now, maybe in your application, you have a use case where you are sandboxing stuff for some reason. But in this use case, transactions are only ever sandbox or not. So that's a clear use case for using a Boolean. But again, for all the other examples we've mentioned, I would think date times work better than Booleans.
Yeah, and it's one of those things where why limit your information when you don't really need to? Now, to be fair, if you can do a Boolean, that's going to be faster for selects and sorts and all that stuff. But that's getting to be less and less of an issue as technology moves forward.
I think the change potential is much more expensive than having a little bit of a larger field.
Yeah,
meaning having to change it from a Boolean back to a date time, or
sure. Yeah, the costs of the changeover are certainly something to consider. However, if I'm looking at this from a customer standpoint, the only thing I care about in that case is how fast is it between the two. I don't care how much it costs you to change it.
It's probably, well, I know, but it's negligible. The
right,
speed is
and
negligible.
That's what I'm saying is until you get into I'm pulling millions of things, that's probably not a consideration you really need to deal with. And even at that point, 10 years ago, that was a much bigger consideration than it is today at 1 million records. And
and once you get a certain size database, if you are pulling, say, you're needing to select by it and you want to have it more efficient, you could use a partial index that only indexes, say, those in the sandbox or not. Or you can only have those in the index that are canceled or not, or are deleted or not deleted,
Right. And by the time you're getting to where a customer is pulling millions of records on a report or something, and this does become a big difference, you probably want to start looking at like archiving and purging records to keep your database trimmed rather than dealing with something like this. So what I'm saying is, unless you know for sure that you're never going to need to know what time this Boolean happened, just make it a timestamp. There's not really a good reason not to. So.
Yep.
All right. So I just want to talk about something that's kind of near and dear to my heart that has been a struggle for me and a lot of people. And that is with testing. Testing timestamps and stuff. It's really hard to test. Not if I can give the program a time and say, hey, it displays like this. That's easy. But if I say, when I delete this record, I want to make sure it gets deleted at timestamp of now. Well, now is different from when it got stamped to when the test is executing the comparison of it. It's not very different, but it's different enough to fail your test. So that becomes kind of a nightmare. So what you really have to do is have some way to freeze time in your tests. And fortunately, in the Ruby world, we have a thing called Timecop. There are similar things in other languages, but Timecop is the one I'm really familiar with because I use it quite often. Basically what it does is it allows you to put a block around some test code. It's not just for tests. You can use it in other places too, but I've never had a use case for it anywhere else but testing in my career. But you can basically put a block around some code and say, okay, freeze time here. Don't let time step forward. Run your code and your expectations, and then you can unfreeze your code. So it kind of freezes time. You can also use it to do time travel. Hey, travel back to 1970 and see how this operates, or travel to the year 2033 and see how this operates, stuff like that. I don't think I've ever actually used that in testing either because I've just never had a need for it. But the big use of things like this is to stop time while you're doing the test to make sure that things are where they're supposed to be if you're testing date times. Now, one of the problems with that is, and this isn't really a Timecop problem, it's more of a language implementation problem of the date time objects, and different languages have different issues. So I'm going to just talk about the issue in RSpec and Rails, Ruby. There's this thing called nanosecond drift that even if you do the Timecop freeze, you have this problem where the nanoseconds don't stop, or they get, I don't know exactly what goes on behind the scenes, but what happens is I put in, it stamps the record with 0 nanoseconds, but when my expectation hits, there's different nanoseconds. There's the actual nanoseconds there. And it's somehow drifted between the two. And that's been a real big issue because it'll cause tests to fail. And you don't always know exactly why, but a lot of times it's because of that. So just to give you some fun things, there's ways to combat that. 2 primary ways. One is you put your expectation and you expect it to be within 1 second of time.now, because all that drifts is the nanosecond, so it'll never go beyond a second of time difference. That's one way to do it. The way I like to do it, though, is to, in my block, when I'm setting up my Timecop, and I say Timecop freeze, I change the nanoseconds to 0, so everything is zeroed out for nanoseconds. So when I do my comparison, they're all 0. Doesn't matter. So then I can do an actual equal comparison, and it's, I mean, functionally, these both work. I like the second one better because it just seems cleaner to me. But hey, that's me.
So why would you, if you're having this problem, why do you even need Timecop if the freezing doesn't work all the time?
Well, it's not that so Timecop actually freezes time, but I think it has to do with a difference in how the nanoseconds are stored to the database and how they're read in memory when you go get to the expectation part. Like I said, I don't know exactly what goes on under the sheets there and what exactly causes this. And for a long time, I didn't know what it was that was causing my tests to fail. Took a long time to figure that out, which was annoying. But I don't think it's a Timecop issue as much as it is a language issue and or a database thing. So, but it's still helpful to, this is the only way I know of to test time issues. If you don't freeze time, you got 0 way of testing them. Well, 0 good way of testing them. You could say, hey, this is within an hour of now.
Yeah.
You know, but that's...
But if that's an acceptable resolution, okay.
Oh, boo. Boo. This is way more fun. Boo.
Well, I mean, I don't use Timecop, and I basically use the same comparison methodology. I like your implementation of be within, a certain span of time. So I may steal that. But I like the same comparisons I was talking about, greater than, equal to, or less than, I would do with a range of, say, a minute or something, and which is acceptable time frame, time resolution for me for all of the tests that I've done. So I've never actually used Timecop. But it seems like a good use case if you have like really fast things you're testing for some purpose.
Which I just ran into last week because I was testing that deleted at, and I had to deal with the Timecop and the INSEC issue, and
Well, I'm saying you don't need. I haven't needed the Timecop gem yet,
right,
for my tests. But I'm saying maybe that becomes more important when you're wanting to test a higher resolution of things. Not that, and this is ignoring the nanosecond problem.
Right, and I specifically had to use this. I use this anyway just because it's cleaner for my brain. But I specifically had to use it in this case because I had to test a series of records getting deleted and make sure that they were deleted in the proper order, that the timestamps got in the proper order. So I had to make sure that the time was frozen and I could see how things were progressing through there, and know that it was, because I also had to check to make sure that it wasn't taking more than so much time between things getting set. So there was an actual use case for freezing time there. And there are a lot of them. I mean, there's a reason this gem exists. People need this a lot, but yeah, and this is the RSpec Timecop speak, but the other languages have similar challenges with testing. So these concepts should help you either either have a time freezer plugin or test that your time is within a certain range of what you're testing for.
Yep.
Anywho, God, I'm about sick of talking about date times. Can we never talk about that again?
Never say never.
Oh, God. Anyway, hope you guys enjoyed that. I actually had some fun. I had some fun researching it because I learned a lot of things about time zones that I hadn't actually known and how stupid they are. Anyway, hope you enjoyed that. If you did, please make sure and mash that like button, ding that bell, or follow if you are on Twitch. We will be here every Wednesday night at 8 p.m. talking about all kinds of stuff. If you have suggestions for a topic that you would like us to cover, please put it in the what's the word? Comments. There's the, holy crap, I'm tired. Put it in the comments and we will put it in our list of things to cover. Also join us on rubberduckdevshow.com. See all our goodies and sign up for newsletters and stuff like that.
And you could, and if you prefer to listen to us, you can check your podcast provider. We should be on all the major ones except for Apple Music or Apple Podcasts. Haven't heard about that one yet, but hopefully soon.
Yeah, I completely forgot.
But you can
podcasts,
listen.
yeah.
But you can listen to the episodes on rubberduckdevshow.com as well.
Right. So if you're driving in your car and you want to hear the dulcet tones of our voices, there you go. You can do that now. So we will see you guys next week. What are we talking about next week? Do we even know yet?
Mystery topic. We don't know. Let's call it a mystery topic.
Mystery meet next week on rubberduckdevshow.com. We will see you then. And until then, happy programming.
Bye.
Bye.